So let us start again. We are actually discussing what is linked list and what is its benefits. Like array, linked list is a linear data structure, but unlike array, linked list elements are not stored at a contiguous memory locations. The elements are linked using pointers. They include a series of connected nodes. Here, each node stores the data and address of the next nodes. That means, suppose this is one nodes, okay, or memory locations, and this is another nodes, one memory location. That means address of this memory locations will be available here, and address of these memory locations will be available here, and address of these memory locations will be here. That means every memory locations are linked to each others. That's why the name is linked list. Okay. Here they are not in contiguous memory locations. It is telling that it is not stored at a contiguous memory location. What does it means? Contiguous memory location means suppose you see, I am giving in one example what is contiguous memory locations. Okay, contiguous memory location, you see, suppose this is one memory locations. Okay, this is one memory location. Suppose you tell this is one memory locations, this is one memory locations, this is another memory location, this is another memory. That means after memory location of this one, this memory is available. In case of arrays, what is happening? Suppose one element is stored here, the next element will be stored here, next element will be stored here, next element will be stored here. If we are storing one row, but here in the linked list, what is happening? Suppose you are storing one element here, another element you can store here, another element you can store here. That is, these memory locations are not contiguous. You cannot tell that these memory locations are contiguous. That means, suppose you are storing one data here, next data will not store here, it may be stored here, next data maybe you can store here, next data you can store here. There is no contiguous memory locations. That contiguous means continuous. After this one, here is the memory, after this one, here is the memory. Okay, this is not happening in case of linked list. Okay, that is known as the actually your contiguous memory location. That what we are telling, that is contiguous memory locations. Okay, so let us discuss the next point. Next point is why linked list array? The size of the array is fixed. In array, what is the problem? The size is fixed. Suppose you are declaring one array of size 5. Suppose 5. Okay, 1, 2, 3, 4, 5. 5 elements you can store, not more than 5. Actually, what is happening during the runtime, we want to increase the size. That is not possible in case of array. Array, it is not possible. Whatever size you have given, that size you have to use. Suppose I have declared an array of size 5, suppose 5. I have given the size 5. You cannot increase the size during the runtime as a 6 or 10. But in case of linked list, you can increase the size during the runtime. That is the main advantage in the linked list. Okay, the size of the array is fixed. So we must know the upper limit on the number of elements in advance. That means whatever the data you want to store, if you want to store 5 elements or 10 elements, that in advance you have to know. But actually in real life program or real life project or real life work, it is not possible to know what is the actual memory requires. What will be the requirements of the memory? You cannot know. It is cannot you cannot find out. That is only it is known during the runtime. Okay. Another problem is insertion of new element and deletion of existing element in an array element is expensive. What is expensive? That means difficult. Suppose you see, we have one array. Okay, suppose we have one array. What is happening, you see? Suppose this is one array. Suppose this is one array. That means here index is 0, here index is 1, here index is 2, here index is 3, here index is 4, like this. Here, what is happening? Suppose you have stored some value here. Suppose 1 you have stored here, here you have stored 2, here we have stored 3, and here we have stored suppose 4, and here we have stored 5. Okay. Suppose you want to insert an element between 1 and 2. 1 and 2 you want to insert an element, suppose 10. How you will insert? Then you have to move all the elements backward. You have to move the elements backward. You move the elements backward. You have to move the elements backward. That means this there is a duplicate element here, 2 is available, and here you can insert 10. Now the new elements will be 1, 10, 3, 4, 5, like this. That means we have to move the elements backwards, and we are creating one space, and in that space we are storing some data. So this process is time consuming. It is a time consuming process. You are moving the element, so it is a time consuming process. So the linked list concept is helps here. What is happening here? Suppose here we are there is a linked list. Suppose you see here in the case of a linked list, already we have drawn one diagram of linked list. Okay. Here suppose you want to insert an element here. That means you just create a memory location here. Here you create a memory location and just make a arrangement. That means you make arrangement like this. Make arrangement like this. Okay. That means we are storing this address of this node here, and address of this node here. That means we are joining one memory location in between these two. So automatically this element is inserted easily. So we have no moving of the elements backwards is required. So that is the one advantage you are getting in the insertion. Similarly in case of also deletions. Deletion also like this happening. You see what is happening in case of deletion, you see. Suppose you want to delete that nodes. Okay, you want to delete that nodes. What is happening? You just making one arrangement of like this. That means you are storing the address of this node here. No need of this node now. Now you can delete that memory location easily. But in case of array, what is happening? That is a problem. In case of array, it is a problem. What is the problem? Okay, what is happening in case of array? You see, suppose you have stored here 1, here 2, here 3, and here 4, here 5 suppose, and you want to delete these elements 3. In case of deletion, what is happening? In case of array, you are moving the elements one step forward, you are moving. That means new situation will be like this: here 1, here 2, and here instead of 3 you are getting 4, and here you are getting 5. That means you are moving the elements again to the forward, which is not required in case of your linked list. In case of linked list, it is not required. You are just making one arrangement of the pointers. You are making one arrangement of the pointers. That I have told. Suppose you are making arrangements. what arrangement you are taking. Suppose you want to delete that element, you want to delete. Suppose this element, this node you want to delete. Okay, this node. What is happening? You can store the address of this node here, and you can delete that nodes. So automatically your problem is solved. Nothing to do. Okay. So these are the things. So insertion and deletion, these are the process, and this process are very easy in case of linked list. Okay, insertion and deletion, they are very easy in case of your linked lists. So these are things. I will supply the nodes. Don't bother about the nodes. I am just doing various type of rough work here. Okay, and so deletion is also expensive with the array until and unless some special techniques are used. Okay, that is special technique that is using here is the dynamic memory locations, or you can tell that that is the your linked list. We are making special arrangements in case of linked list. Okay. Now, drawbacks is the random access is not allowed. We have an access to elements sequentially starting from the first node to the last node. Cannot be binary search. We cannot do the binary search with the linked list efficiently with its default implementations. Okay. Extra memory space is required for a pointers. We are using one pointers. That means to store the data, we have to use pointers. You see, one memory location is required here, pointers. Pointer memory location is required. That means one memory location is required to store the address of the nodes. So extra memory location is required. Here you are storing the address of the next nodes. So this is the advantage and disadvantage, and we have already covered all the drawbacks. As the elements are also not contiguous, it is also a problem. Okay. Okay. In next class, I will show you how you are creating the linked list and how you are displaying the linked list. Okay. For today, I am closing this class. Thank you.